on lesson 12.3, operations with functions, and we are going to be multiplying and dividing functions today. So first off, what is function notation, which we've learned in other sections? Function notation is just that fancy way of saying y equals. It's like f of x equals, g of x equals, or h of x equals. And the whole point of using the different letters there is to show that we're talking about different functions. So we'll have a list of separate functions and the letter tells you which one we are selecting. Okay, when we are multiplying together functions, we're going to treat it like multiplication, as in like the distributive property. Okay, so we're going to take two functions, put them in separate parentheses, and then distribute. And as we distribute, we need to remember that we are adding together the exponents. Okay. After we distribute, we then want to combine like terms where the exponents match each other. So things, if they're like x squared and 5x squared, we can combine those together. Okay, remember when we combine like terms, we keep the exponents. So you distribute, you add the exponents. When you combine like terms, you keep your exponents. Okay, the last thing we're gonna do is dividing. And when you divide, you write as a fraction. Okay, so we should write a fraction bar, put something on top, and put a different function on the bottom. Okay. When we are checking our fractions, there's not really much we have to do with them, but we do need to check the denominator to make sure that the domain shows where the denominator equals 0. Okay, a few sections ago in Unit 11, we set denominators not equal to 0 and then we solved. We were searching for extraneous solutions or just points where that fraction doesn't exist. Okay, so wherever I have written domain on the paper, that's where we are dividing only, not multiplying. So we set the denominator or the bottom of the fraction not equal to 0, and then we solve to get x by itself. So we're finding the x values where the fraction is undefined. All right, let's take a look over here at example 1. It says f times g of x. So just like in previous sections, we are going to do f of x. We're breaking this up into f of x, and then put a little dot for times, that dot right here, and then g of x. Use this color. Okay. Since we have the letter x here, that means that we are keeping x in our answer, so we don't have to plug in an additional number after we figure out what we get when we distribute. So f of x is 5x. We can put that in parentheses like this, and then g of x is 3x squared. Put in parentheses like that. Okay. When you have two sets of parentheses right next to each other, it means multiply, so you can put that dot or you don't have to, your choice. Okay, we have one term times one term. Okay, 1 times 1 is 1, so we are only going to get one term as we multiply this out. So 5x times 3x squared, we're going to multiply 5 times 3 is 15. And then x times x squared, we're going to have x to the, remember that this little x has an invisible exponent of 1, so 1 plus 2 is 3. Okay, so f times g of x is 15x cubed. Okay, example 2, we have g over h of x. That is going to be the same thing as, draw a fraction bar, g of x is going to be on top because g was on top here. So g of x is our numerator. And then h of x is in the denominator on the bottom because h was there on the bottom. So h of x. Okay, so that's what we're doing. Let's draw a fraction bar and actually write out our stuff. So g of x was 3x squared. H of x is negative 2x plus 6. Okay. We are done with this, okay? That fraction is g over h of x. But we do need to check the domain to make sure that the denominator does not equal 0. So we're going to say negative 2x plus 6 equals 0. And I'm going to put a slash through the equal sign to show that we do not want the denominator to equal 0. Okay, let's solve this guy. Subtract 6 from both sides. Get negative 2x does not equal negative 6. And then divide both sides by negative 2. So we get x does not equal, negative divided by negative is positive, 6 divided by 2 is 3. Okay, so the domain of our function means what are all of the x values that we are allowed to plug in for x here and here. We are allowed to plug in anything except x equals 3 because 3 would make our denominator equal 0, and denominators are not allowed to equal 0 because we can't divide by 0. So our domain is all real numbers except x cannot equal 3. Okay, we only have to do that on the problems where we have a fraction, where there's x's in a denominator. All right, over here, example 3, it says g times h of negative 4. So let's find what is g times h of x first off. So this is going to be g of x times h of x. Okay. G of x is 3x squared times h of x has two terms, negative 2x plus 6. Now you might notice that this time I did not put the 3x squared in parentheses. It doesn't really matter if there's just one term if you put it in parentheses or not. So we could have just put a dot instead of parentheses like on number 1. Okay, we have one term on the outside of the parentheses and two terms on the inside of the parentheses. That looks a lot to me like distributing. So let's take our one term outside times the two terms inside. 1 times 2 is 2. So we're going to get two terms as we multiply. So let's do it. 3 times negative 2 is negative 6. X squared times x to the first power is x to the third power, or x cubed. And then 3x squared times 6. 3 times 6 is 18. It's positive, so we'll put a plus. So plus 18. We've got x squared here and no more x's, so we'll just keep the x squared that we have. Okay, so this, what we have is g times h of x. But what we want is g times h of negative 4. Okay, so let's find g times h of negative 4 by plugging in negative 4 everywhere we have an x there. Okay, so this is going to equal negative 6 times something cubed plus 18 times something squared. And inside those parentheses, we're going to put the negative 4. Okay, at this point, you are able to just plug this whole right-hand side into your calculator. Make sure that you use parentheses every time you plug in one of those negative 4s for several reasons. One, you want it to make sure it doesn't look like subtraction. Another thing, as you cube and square, sometimes your exponent will force the negative 4 to turn positive as you multiply it out. So whenever you have an exponent that is odd, you will end up with a negative number if you started with a negative. If you start with a negative and you have an even exponent like a 2 or a 4, you'll end up with a positive number because negative times negative is positive. All right, I'm going to go ahead and work this out by hand, but you are welcome to plug that straight into a calculator. Alrighty. As we plug in negative 4, we are going to do the exponents. This is PEMDAS, order of operations. So we're going to do negative 4 cubed. Negative times negative times negative is negative, and 4 times 4 times 4 is 64. Okay, over here, negative 4 squared, negative times negative is positive, 4 times 4 is 16. Okay, our next step is multiply in PEMDAS. So let's multiply. Negative 6 times negative 64 is positive 384. And 18 times 16 is 288, so plus 288. Okay, and then when you add 384 and 288 together, you get 672. That was quite a large number. Okay, we knew we were supposed to get a number for our answer because we had a number that we were plugging in. Alrighty. Number 4. Number 4 is a lot like number 2. We have a fraction, and we are going to plug in one of our functions on the top of the fraction and one on the bottom of the fraction. The bottom of our fraction is f, so f of x is in that denominator. The top of our fraction is h of x because h was up in the numerator. Okay, now let's actually rewrite it with h of x, the function itself, which is negative 2x plus 6, and f of x in the denominator, which is 5x. Okay, our domain is that x can be any number it wants to be, except for whatever makes that denominator equal 0. So let's take that 5x and set it not equal to 0, and let's solve that. Okay, let's divide both sides by 5. 5 divided by 5 is 1, so 1x cannot equal 0 divided by anything is 0. Okay, so x is allowed to equal any real number except x cannot equal 0. That is our domain. Okay, in the previous problem, number 2, we used the h of x function when we did domain because h of x was in the denominator. Forgot to make it purple, but there it is. All right. As we look at the next set of problems, I'm going to use the calculator on some of them. So if you want to pause right now and plug in f of x into x1 or into y1, g of x into y2, and h of x into y3. I've already done that. Okay, so you hit y equals and then plug into those 3 spots. All right. I've already written out how we kind of separate everything. So on number 5, we have f times g of 5. That means we need f of x times g of x and then plug in a 5. Okay, we already found f times g of x on the previous set of problems, but notice that we have new functions for examples 5 through 8, so we cannot just use what we had up here. Okay, f times g of 5. F of x is 4x minus 5. G of x is 6x plus 4. Okay, we're going to distribute. We have 2 terms times 2 terms. 2 times 2 is 4, so we're going to get 4 terms as we multiply out. I'll draw each curve as I do that part. 4x times 6x is 24x squared, because x times x is x squared. 4x times 4 is 16x. 4x has been multiplied times everything, so move on to negative 5. Negative 5 times 6x is negative 30x. And negative 5 times positive 4 is negative 20. Okay, so every time we multiplied several x's together, we added the exponents together. Anytime we had an x times just a regular number, you just kept the x that you had. And if there's no x's, you still have no x's. All right, the last thing we do is combine like terms, and we have two like terms here in the center. That is a really common pattern that we end up getting. 24x squared does not have a like term. 16x minus 30x is negative 14x. And we just bring down that negative 20. Okay. Now this right here is f times g of x. We want f times g of 5. So we're going to take a 5 and plug it in everywhere we had an x before. Don't really have a ton of room here, so I'm going to put it on several lines. F times g of 5 is 24 times 5 squared minus 14 times 5 minus 20. Okay, our first step in PEMDAS is simplify 5 squared. 5 squared is 25, so we've got 24 times 25 minus 14 times 5 minus 20. Next step is multiply. We've got two multiplications. 24 times 25 is 600 minus 14 times 5 is 70, and bring down the minus 20. Okay, now we can just subtract 70 and subtract 20 from 600, which is 510. Okay, I said I was also going to show you guys how to do that in the graphing calculator. Okay, so I've got all of my functions plugged in here. I'm going to hit second and then table. Okay, so these are the x values that got plugged in to f of x, into g of x, and into h of x. Okay, so negative 25 is f of negative 5. Negative 26 is g of negative 5, and 67 is h of negative 5. Okay, the number that we plugged in was a positive 5. So we're going to look for where x is 5, which is way down here at the bottom. There it is. Okay, we were doing f times g of x. So f times g of 5, or f of 5 times g of 5. So if you take a look, f of 5 is 15 and g of 5 is 34. If you multiply together 15 times 34, what do you get? Well, I'm going to hit second and then mode for quit to get back here. And we were multiplying together 15 times 34. Those were the two numbers that we got from the table. And we have 510. Here's 510. So it's pretty quick if you have a calculator to just plug in your functions into the y equals and then look at the table. Okay. That does not quite work on example number 6 though, where it says f times h of x. So we do get to stop as soon as we get the x plugged in and everything all multiplied out. So we are not going to plug this into our calculators. Okay, we're still going to have x's in our answers. Okay, f of x is 4x minus 5 times h of x, which is 3x squared minus 8. Okay, just like on number 5, we are going to distribute. 4x times 3x squared is 12x cubed. 4x times negative 8 is negative 32x. Negative 5 times 3x squared is negative 15x squared. And negative 5 times negative 8 is positive 40. Okay, the only thing we have to do on this now is put it in standard form. Standard form means biggest exponent all the way down to smallest exponent, or the constant being last. Our biggest exponent is a 3, 12x cubed. Next biggest exponent is a 2, negative 15x squared. Then we just have our linear term x, negative 32x. And our constant term is last, which is positive 40. Okay. Even though the instructions say to state domain restrictions, there are no domain restrictions because we do not have a denominator. We will, however, have to do domain on number 7 because we do have a fraction. Okay, our fraction is g of x over f of x because g was on top and f was on the bottom. Okay, so we're going to rewrite this. G of x is 6x plus 4. And f of x on the bottom, 4x minus 5. Okay, the whole part about domain is that we are not allowed to divide by 0, so we take the denominator, 4x minus 5, and say that it's not allowed to equal 0, and then we solve this for x. So add 5. 4x is not allowed to equal 5, and then divide both sides by 4. X is not allowed to equal, so this fraction doesn't really simplify well. You could rewrite it as just 5 over 4, that's fine, 1.25 or 1 1/4. I'm just going to leave it as 5/4. Okay, so our domain is x is allowed to equal all real numbers except x cannot equal 5 over 4. We don't care about the numerator because tops of fractions are allowed to equal 0. All right, number 8, f times f of negative 3. So we are going to do f of x times f of x, and then we're going to plug in negative 3. There's several ways to do these problems. I will also show you on the calculator on this one. So f of x times f of x. That's 4x minus 5 times 4x minus 5. Let's distribute. 4x times 4x, 16x squared. 4x times negative 5 is negative 20x. Negative 5 times 4x is negative 20x. And negative 5 times negative 5 is positive 25. Okay, this is squaring a binomial, so if you had a pattern that you know, you are allowed to use it on this. Combining like terms and putting in standard form, we put our biggest exponent first. We have two like terms here in the center. They have the same sign, so we're going to add them together, negative 40x, and then plus 25 at the end. Okay, if this problem said f times f of x, we would be done. However, it says f times f of negative 3. So f times f of negative 3, that's what we're plugging in. Okay, so we've got 16 times negative 3 squared minus 40 times negative 3 plus 25. So everywhere we saw an x, we're putting in negative 3. Okay, for PEMDAS, the first thing you do is square. So negative 3 squared is positive 9. And then copy everything else. Next up, multiply. We have multiply with our 16 times 9, which is 144. Negative 4 times negative 3 is positive 12. And bring down that plus 25. Then we can add all these numbers together. 144 plus 12 plus 25 is 181. Okay, now let's take a look at what we would get oh my goodness, I missed that 0. 40, sorry, that's 120, which means that I added wrong as well. Okay, so let's fix that mistake. Negative 40 times negative 3 is positive 120. So 144 plus 120 plus 25 is 289. All right. All right, so I'm going to go back to that y equals. Our y equals had f of x as y1. Go back to that table. Okay, we plugged in the number negative 3 for x. That's here. And then y1 says that f of negative 3 is negative 17. Okay, so if we did f of -3 times f of -3, we would end up with -17, which is the answer that our calculator gave us in the table, times -17. And if you multiply -17 times itself, you get positive 289. Right, so it doesn't matter if you do it in the calculator or by hand, you should get the exact same answer, as long as you don't forget to write in part of your problem.